Okay, good afternoon. This is the 21st lecture of this series, Python for Machine Learning, as your third semester minor in computer science. So I will be winding up this course today, as I had mentioned earlier. And I will announce regarding the evaluation schemes, etc., towards the end of the course. We will. So we have been looking at Python for probably probably around 3 months right now, and we started off with the Python environment, I mean the Jupyter environment. Then we tried various programming constructs. Then we moved on to objects, and then Python modules. So we looked at modules for system accessing system variables, file handling, then probably for a new NumPy or scientific computing, plotting, and finally, I think the last couple of lectures were regarding pandas, the structure for handling array data or data frames. And so I think we have completed almost every topic mentioned in your syllabus. And to be frank, your syllabus is already very little, actually. Many necessary things are missing in the syllabus. But still, I think this is a fine introduction to your Python programming language. And today, to conclude, so I will demonstrate an application, especially. So you are supposed to learn a remaining part of machine learning in the later part of your course. Maybe I think for a minor, you have to take 3 more courses in the succeeding semesters, and you have to do one project at the end. I hope at least some people will survive through the 5 semesters, the coming 5 semesters. Today, I will demonstrate an application, how people apply machine learning using Python to a real problem. So that will be an apt conclusion. So we have been looking at the iris dataset, flower dataset a couple of lectures back. I hope at least some of you remember. So iris was a kind of flower found in California, some valley in California, and Ronald Fisher collected 150 samples from these flower data set, and he compiled some data, and the data depending on the length of its petals and sepals. So we will design using that data set. I think we try to read that into a data frame or some list, etc. in the last lecture. So using that data that we have, we will try to find out or determine the type of a new data instance. So I will tell you what setup we have. We have 150 examples of iris flower. So 50 each. I think there are 3 kinds of irises: Setosa, Virginica, and what was the other one? One more was there. Okay, so out of these three kinds, so they differ in sepal length, petal width. See, these are the 4 different features we have. Now, with this 150 known data, we are sitting with a computer, and suddenly somebody is coming to you with some measurement, say sepal length 5.7, petal length 2.8, 3. Say the other 2 things. So some 4 values are there. See, somebody measured some unknown flower or from in the field and sent you the values of these 4 parameters. Now you are you have to predict to which class of iris this belongs. That is your problem. I hope you understood. So we have 150 data, 150 known data, and there is one unknown instance which we have to find out to which class this belongs to. The training, so the known data set, so with the one with the values known, we call it as training data. So here in this case, in our case, we have 150 instances of training data. 150 instances of training data. So using these 150 instances, you have to design some kind of a machine learning algorithm. So you should design an algorithm such that a new instance can be classified. Or say an unknown flower with the parameters comes in, you should say that this belongs to this particular thing or that particular thing. So this is our problem. So one solution for such thing is that we take the new unknown data, we compare the data with the training data, or what we do is we find out say k number of nearest data. So we have an unknown data, we find out say some k number of k is an arbitrary number, say it can be 5 or 3 or something. So say നമുക്ക് കിട്ടിയ ഡേറ്റ പോലത്തെ അതിനോട് സാമ്യമുള്ള സിമിലാരിറ്റി ഉള്ള say 5 additional data കൂടെ നമ്മുടെ ട്രെയിനിങ് ഡേറ്റ സെറ്റ് നമ്മൾ കളക്ട് ചെയ്യാനിരിക്കട്ടെ. Then so we are limited to 5. നമുക്ക് ഇതിനോട് സിമിലർ ആയിട്ട് മാച്ച് ആവാൻ 5 എണ്ണം ഉണ്ട്. അപ്പൊ അതില് majority ഏതാണ്? majority സെറ്റോസ് ആണോ, majority വിർജീനിക്ക ആണോ, അല്ലെങ്കിൽ ഏത് കാറ്റഗറിയാണ് ഇതിനോട് നിയറസ്റ്റ് മാച്ചിങ് ഉള്ള മാക്സിമം നമ്പർ വരുന്നത്? We will say that this belongs to that. That is the idea behind k nearest neighbors. So you choose k neighbors of this particular unknown flower. We choose k neighbors of unknown flower and find out which is in majority, which category is in majority among these 5 neighbors or this k neighbors. And we say that our unknown flower belongs to this new or that particular majority data. That is what we are going to implement. So let us see how we go ahead implementing such a scheme in using Python. See, we will be using all the tools and techniques that we have seen so far. So let us straight away go to the presentation. So where is my projection? Okay. Yeah. Okay. Are you able to see? I think so. Okay. It's coming up. Okay. It's coming up. Okay. So I will state the problem again. This is our iris flower. There's a sepal, there's a petal. Our features we have measured: sepal length, petal sepal width, petal length, and petal width. There are 3 kinds of your iris flowers: versicolor, setosa, virginica. And our problem is to find out a new flower to determine to which category a new flower belongs to. So our data set. So where is our data set? Let's see. Let us look at our iris data set. Our iris data set is like this. See, we have sepal length, sepal width, petal length, petal width, and variety. This is what is given as a training data. So 50-50 each. So given the new data set, so the outline of what we will do is written in these comments here. So we will actually read our data set. That is what we should do first. Then, so that is the first step. So we will read it. Then we will do some amount of pre-processing on the data. Why? I'll tell you why. I will explain why we need it later. So then, once we pre-process, once you read and pre-process our data, so we have the measurements of the new flower. So this is our new flower. This is your length, petal length, sepal length, petal width, sepal width. Then you will say we will ask our program to look for 5 neighbors, 5 nearest neighbors. We will be looking using our program. We will be looking at 5 nearest matching neighbors of this particular unknown flower. This unknown flower ante 5 ayalkare nammal kandathu. So that is what we are going to do. So that is why we have number of neighbors is 5. So we can set it to 3 or 7 or something, whatever you want, you can do. Then we will do a prediction. So which class predict? So we'll write a function. We'll write this kind of a function. It will take your data set. So that is your data set, your new flower, and your number of neighbors into this function. This function will return what is the new flower, and you will print it out. That is what your plan is. Now, this is what is that. This is the outline of our program. So we will do it step by step. So when you write this kind of a program, don't get panic. We will the first thing we need to read this particular data. So for reading the data, this is what I did. So I know the values in CSV. I think we have looked at methods for reading comma separated values earlier, and this time I am writing a function load CSV. I'm writing a small function so that our code will be modular. So which will accept my file name as a data. I mean, as an argument. So the advantage is that next time, if you have a different file name, you can you can just change the file name here, and the program will work. So this is my first step. As a first step, so let us see how this works. So we have to write this load CSV function. So this is my load CSV function. So I think there's a CSV library. There's a CSV library actually. You can import that CSV reader from CSV library, and this is my function load CSV module function. So it accepts a file name. So I am going to keep my data in a list rather than a data frame. You can also keep this in a data frame, but the entire code you will have to rewrite. Okay. Here I am creating an empty list which will hold my data set. Now I am going to open this iris.csv. Open iris.csv with a file handle file. It's open in read mode. Now I read file. So the entire file has been read to a variable named CSV file. So this is my CSV file. So once I have read this, I have read entire thing into CSV file. I process row by row. So I read the first row for row in CSV reader. So I take the first row. So this will be supplying row by row, and I will be appending that to the data set. The data set is a list. So I will row wise, I will be appending to the data set. So once you do this, once you complete this step, I will return the data set. So this is, let us see how the output look like. So so I'm loading the data set. So okay, now I'm printing the data set here. See this one. So our entire thing has come in as a data value here. Data value here as a set of data values. So it's kind of list of lists. See, you see it's a list of lists. See the square bracket here. Square bracket here. The first row on the list is this. Second row is this list. Third list. The fourth list. So it's a kind of list of lists. We have read this into as a list of lists. Now, if you carefully examine this data, so the first row or the zeroth row in Python, it will be the zeroth row. The zeroth row, so where is this? Zeroth row is actually some headings. So this is not needed for us. Actually, for later on, for the data processing, these headers are probably needed when you print out or do something. The real data handling or data processing, we don't need this data. So you have to remove this. So that is very easy. You can remove the first row. And then if you look here, you see the values. The values 5.1, 3.5, 1.4, 2.2 Setosa. This particular value, if you carefully look, the values are not integers or floating point numbers. 5.1 is actually a floating point number. But here, our CSV reader has somehow read it as a string. But you need to convert these values to integers. So that 4 columns, there are 5 columns in the data. So you have to remove you have to convert first 4 columns into numbers or some kind of numbers. And if you look at the last column is the category type, variety type. See, there are 3 varieties we know. But it will be convenient in such cases if you keep numbers instead of strings. See, you can say that Setosa is category 1, versicolor is category 2, or Virginica is category 3. You can replace these strings with numbers for easier processing. So it is always easier to handle numbers. So we, as a first step, that is a pre-processing step, we will process this particular data by removing these values. Say the first row, the headings, removing the string values from instead of converting the strings to floating point numbers or integers. So that is our next step. So let us go ahead and do that. The first thing, that is the headings or the first headers can be removed very easily. So data set dot remove, say the first column, first row you can remove. So actually this is a list. So we are using we are having a list of list, and we are removing an element from a list. So the element to be removed is the first data 0. So we will remove it. Let us run it and examine what happened. Now our data set, if you look at it at the beginning of the data set, that first line is gone. First line is gone. We have only the necessary values. Now let us go ahead and remove the column. First, look at the first column. So that is a set of strings. So we need to change that to some kind of floating point numbers. So we will write one small function here. This is a very simple thing. So you have a look at it. String column to float. So string as a column containing strings to float. I am accepting data set. I am accepting a column. So I need to repeat this for 1, 2, 0, 1, 2, 3. So for the 3 column, when 4 columns, I have to repeat the same thing. So what I will do is this. It's a very simple thing. Let us do this for first column. So this is let me explain this. So I will take the so your function is getting data set and a column number as input. So you take the first row from the data set. First row. So now first row, the first say column. Now if you are going to convert all elements of column 0, you take row of column 0. So that is, I take the first element here. That is in the case 5.1 here. Take the 5.1. Then you convert it into float. So here is your floating conversion. You convert this to float and then assign back to the same value. This particular value assign. So then you will see that when I am converting to float, there's a strip function. See here, the strip function strips off any trailing or succeeding spaces. String ആണ് നമുക്ക് കിട്ടിയിരിക്കുന്നത് ഈ വാല്യൂ സ്ട്രിംഗ് ആണ്. അപ്പോൾ സ്ട്രിങ്ങിന്റെ അപ്പുറത്തും ഇപ്പുറത്തും സ്പേസ് ഉണ്ടെങ്കിൽ അതിനെ സ്ട്രിപ്പ് ചെയ്ത് കളഞ്ഞിട്ട് ഞാൻ അതിനെ ഫ്ലോട്ട് ആക്കി മാറ്റി ആ ഇൻഫർമേഷൻ തിരിച്ച് അതേ സ്ഥലത്ത് തന്നെ തിരിച്ച് സ്റ്റോർ ചെയ്യും. അപ്പോൾ so if I do this, let's see what happens. I will do this for column 0. So first column I am going to see and examine what happened to our data. Column 0 ile ഇത് ഞാൻ റൺ ചെയ്തു. അപ്പോൾ now you see, if you see here, the first item has been converted to float. This is float, but still these three are strings. So we will again rerun this for all. Now, so let me build up the program. Now that we have built our first function, let us build that program. So I will read it. So this is what I do. This is what I do. So I will read the data set. I will load the data set. I will remove the first row. Then I will for 0 to 3, 0, 1, 2, 3. That is for 0 to 3. For 3 columns, first 4 columns, I convert the string values to floating values. This is what I did. So I called that function in a loop. The function that I defined in a loop. 0 to 3. 0, 1, 2, 3. These columns are good. Now let me run it. Let me rerun it and look at the data set again. So okay, where is this? Okay, this was the first one. This is what we did now. Now, okay, if you go here, yeah, see here all the rows. For all the rows, first 4 numbers, first 4 strings have been converted into floating point numbers. Now we can process these numbers. Now there is one more thing. See, these strings, they don't look very nice. We can keep setosa. We can use integer classes. For each classes, you can say we can give numbers. For that, again, I will write one small column, small function, string column to integers. So this particular function, this particular function will read the last column. I will read the last column. Find out what are the unique values in it, unique strings in it. We see in many places, in many big data sets, you will have no clue on what character, what are the types available, etc. So I am showing you a very simplified model in which you can use this same model. You can reuse in your own problems. So what I will do is I will write a function which will convert one particular column to into numerical value. See, this column has string categories. So let us look at it. What I have done. So my function has 2 inputs: a data set and a column number. Say here we have 0, 1, 2, 3, 4th column. So 4th column you have to convert. So what I will do is I will find out what are the values in the 4th column. 4th column, what are the values? You remember, our data is kept as a list of lists, not as a data frame. See, if it was a data frame, the thing was very easy. But my intention here is to teach you how that actual coding process or machine learning idea is developed. If you can very easily use a data frame to do all these things quickly. So what I do is I do an iteration over the data set. Over the data set, I do an iteration and convert and take all the 4th columns or the last column to collect to a list value like this. See here, say for row in data set, I will take the 4th value from that 4th row and keep it into a list. Keep that to a list. So this will create a list with all the values in the last column. See here, the last column alone was extracted from this. Now, I think there are 50 of each, Virginica, Setosa, and versicolare, 50-50. We have to find out what are the unique sets, unique values there. So there is a function called unique. Then when you see run a unique, you will say that what are the unique values. So we have only 3 that this guy has returned. Now you need to make Setosa 0, Virginica 1, and versicolare 2. So we will assign numbers 1, 2, 3 to each of them. So for that, what we will do is, say I'm going to create a dictionary here. I'm going to create a dictionary. Okay, wait. This is not needed now. So I will do something called, we will use something called enumerate. Enumerate this list. Our original Setosa, I mean, this particular class values, we are going to enumerate. So when you enumerate it, run. Let's run. You will get this kind of a dictionary. Say 0 Setosa, 1 Virginica, 2 versicolare. This way we changed it. Now if you look at this one, your string to colon function, I process the data set this way and convert or change each of the values here, these category values, to numbers. So you can find out the logic here. I'm not explaining the logic. You can, so I'm iterating over that enumerated value. Then for each one, I am adding something to a lookup table. So when I do that, it's okay. Now let us come back to our original code. I have this particular new function also. So here I have, I will be rerunning. I'm loading the data, removing the first thing. So making things to float, and the last column I am going to make it to category values. Now let us see. If you look at the data set again, if you look at the data set, say that, look at the first column, first row, see these values are retained, the actual lengths are retained, and instead of category Setosa, we put 0 because we have mapped Setosa to 0, Virginica to 1, and this is for our computational convenience. Now our data is ready for machine learning tasks. So in any kind of data you are working with, maybe later in your career, the first thing you have to do is you have to collect the data, process it, pre-process it, and make it ready for further processing. Now let us look at what we are to do. Now everything is ready. You have your data sets. Now we have to find out 5. Say now the new data, flower data comes in. Pudiya pointe data oralu kondathira. Appo ninga data ready. Ninga training data ready aanu. Somebody is bringing in a new flower data. Say 5.7, 2.9, 5.2, 1.3. You have to find out who are the 5 neighbors of this particular flower. See, you can always choose 2 neighbors, 5 neighbors, 10 neighbors, whatever it is. The number of neighbors you can choose. But in this case, as an example, I have chosen 5 neighbors. And among the 5 neighbors, we will find out who are the 5 neighbors of this particular flower. But adine namukku oru neighbors compute cheyanayittulla oru code ezhudana, oru program ezhudana. Who are the 5 neighbors of our flower, new flower. So we will write a small code. We will write a small code here. I'll explain what it means. So our neighborhood of this particular new flower is computed using some kind of a Euclidean distance. So I hope you remember the distance between 2 points in your 3D classes, 3D geometry classes. X2 minus x1, y2 minus y1, z2 minus y1 whole square. That x2 square root of x2 minus x1 square, y2 minus y1 square, plus z2 minus z1 square. So that was the Euclidean distance formula. Now here we treat we treat the data in such a way that we are in a 4-dimensional Euclidean space. Instead of x, y, z, we will say that we have one more parameter, x, y, z, say p, x, y, z, and one more data parameter, and we compute the distance or Euclidean distance of each of the 150 training points from our unknown flower. നമ്മുടെ unknown flower ഇന്ന് ഓരോ മറ്റ് 150 പൂവുകളിലേക്കുള്ള ഡിസ്റ്റൻസ് കമ്പ്യൂട്ട് ചെയ്യും. അപ്പൊ നമ്മുടെ ഏറ്റവും അടുത്ത നെയ്ബേഴ്സിന് ഈ ഡിസ്റ്റൻസ് വളരെ കുറവായിരിക്കും. ഡിസ്റ്റൻസ് അപ്പൊ നമ്മുടെ ഏറ്റവും അടുത്ത നിയറസ്റ്റ് പോയിന്റിലേക്കുള്ള ഡിസ്റ്റൻസ് ഏറ്റവും കുറവായിരിക്കും. നമ്മൾ ഈ 150 എണ്ണത്തിലേക്കുള്ള ഡിസ്റ്റൻസ് കമ്പ്യൂട്ട് ചെയ്തിട്ട് അതിനകത്ത് ഏറ്റവും ഷോർട്ടസ്റ്റ് ഡിസ്റ്റൻസ് ഉള്ള 5 എണ്ണത്തിന് എടുക്കാൻ പോവുകയാണ്. അപ്പോൾ ദാറ്റ് ഈസ് വാട്ട് വി ആർ ഗോയിങ് ടു do here. So our get neighbors function is actually we are going to find out Euclidean distance between 2 points. We are going to find out Euclidean distance. So let us come to that. So here is a function that I wrote for finding out Euclidean distance between 2 points in 4-dimensional space. This one you can compute in 5-dimensional, n-dimensional space. The Euclidean distance formula in our 3D generalizes to any dimension. So this is what I did. Here is your formula, square root of see that x2 minus x1 square I have computed. Then there's here I am computing the square root. So this function, using this function, I will compute this square root. So you can, if you are in doubt whether this computes, say I will give you two sample examples. X is this one, y is this one, and let us find out the Euclidean distance. This will return this kind of a value between 2 points, 2 Euclidean distance points. Now, our get neighbors program, it takes our data set, new flower, and number of neighbors. So let us run it here. We have said this. We have this data set. You have. If you run it. This okay, what happened? I think I did not run these values here. Get neighbors have to run. Then what else? Okay, this one do. Okay, so this will return 5 neighbors, nearest neighbors from your data set. Say if I put a 4 here, it will return 4 values. If I give 10, it will return 10 such values. So this actually, now let us look at this code. This actually this is the code. It actually creates a list of nearest neighbors. So what we are going to do, you compute the Euclidean distance with each point. So this is what is, you compute the Euclidean distance of each of these points, and then you sort the distances, and the first say k numbers or 5 numbers you are returning. Your first 5 numbers we are returning from these values. So if you are in doubt, I will leave the code to your Moodle. You can run it step by step. So once you got this one, once you got these neighbors, 5 neighbors, you need only extract. So these are the neighbors. So if when you have the neighbors, you need to extract only the last value of this. See here everything is same. All the 10 or 5 or whatever it is, they are having the same. Now you have to compute. These values. Which are the nearest values or 5 values of this one. Which are the nearest categories of these 5. ഈ 5 കാറ്റഗറി നിയറസ്റ്റ് 5 എണ്ണത്തിന്റെ 5 കാറ്റഗറി എടുത്തത്. ഇവിടെ എല്ലാം ഒന്നുപോലെയാണ്, പക്ഷേ ചിലപ്പോൾ ഇത് വ്യത്യസ്തമായിരിക്കും. ചിലപ്പോൾ 2 എണ്ണം ഒരു കാറ്റഗറി, 3 എണ്ണം വേറെ കാറ്റഗറി ആയിരിക്കും. ഏതെങ്കിലും ഫ്ലവറുമായിട്ട് സാമ്യം കുറഞ്ഞ് 2 എണ്ണമായിട്ടും കുറേ സാമ്യം ഉണ്ടാവും. അപ്പൊ അങ്ങനെയാണെങ്കിൽ ഇത് എല്ലാം ഒരുപോലെ ആയിരിക്കണം. ചിലത് അല്ലെങ്കിൽ കാറ്റഗറിയുടെ നമ്പർ വ്യത്യാസം ഉണ്ടാവും. ചിലത് 2 കിട്ടും, ചിലത് ഇപ്പൊ ഇഫ് യു ഗെറ്റ് 2, 3, so actually you can change some value there and you find out how it behaves. അപ്പൊ ഇനി ഇതിന്റെ മാക്സിമം ഏത് കാറ്റഗറിയാണ്? ഇതിപ്പോ എല്ലാം 2 കിട്ടി. അപ്പൊ ഇതിന്റെ കാറ്റഗറി നാച്ചുറലി ഈ ഫ്ലവറിന്റെ കാറ്റഗറി മിക്കവാറും 2 എന്ന് പറഞ്ഞ കാറ്റഗറി ആയിരിക്കും. 2 എന്ന് പറഞ്ഞാൽ നമ്മൾ സെക്ടോസ് അങ്ങനെ എന്തോ നമ്മൾ മുകളിൽ കൊടുത്തിരുന്നു അല്ലേ. സോ that you can print. Your prediction, your actual prediction will be to find out maximum. ഇതിൽ ഏതാണ് മാക്സിമം ഉള്ളത്, അല്ലെങ്കിൽ മാക്സിമം നമ്പർ ഓഫ് ടൈംസ് വരുന്നതെന്ന് കണ്ടുപിടിച്ചാൽ മതി. ഏത് നമ്പറാണ്, ഏത് കാറ്റഗറിയാണ് മാക്സിമം വരുന്നതെന്ന് കണ്ടുപിടിച്ചാൽ മതി. So that will give you a prediction. So our entire thing is done. Your entire program is done. So we have written the entire thing. Now only you have to assemble these stuff. So let us assemble everything into a single program. So here I am importing square root, importing math CSV reader. See this everything we have moved to the first beginning. Then your first function is to read the CSV file. Number of neighbors you have to find out. For finding out neighbors, you need to order that Euclidean distance. So from the number of neighbors, you predict the classification, which is the best classifier, which is the nearest neighbor. This we predict. And you need some supporting function for these two functions for data, cleaning up your data. These two are for cleaning up your data. And once you are done, your entire thing is done. See, these are your set of functions. And here is your set of the actual code. Now, if you see this code is very simple. See, you are reading the file. You're reading the file, pre-processing it here up to this point. We are pre-processing. Here you are reading and doing that. Then here comes a new flower, and you predict what type of flower it is. So let us run it. So 2 is whatever. Predict classification. And then I think we have to run this one. Run this and then run. I did not run it. Okay. Now, if you predict the flower type is 2. 2 is your versicolor. So we gave the value for a versicolor. Now, so your new thing is done. Now let us change it slightly. So I'm going to make it 3.7, 1.9. So value I'm going to change. Maybe 1.2. This I think going to 5. So let us run this again. So what is the flower type? So that is 0. The new value I gave, this random, I gave it randomly. Even though I gave it randomly, if you get measurements like this will be a Setosa. That Setosa flower. So you have designed and implemented a very small machine learning program. Very small machine learning program in which you can predict the value of any unknown flower. See, you give the values. Our code will predict some new value. So this is how a typical machine learning problem is solved. So the sequence is like this. You get hold of data, you pre-process it, make it properly working. Then you implement an algorithm, machine learning algorithm. Here I have implemented k nearest neighbor algorithm. It's in a very couple of 3 or 4 functions. Maybe you can compress this further. If you use a data frame, if you read that CSV into data frame, many of the pre-processing things are good. You can straight away manipulate column wise, row wise, say all those things are there. Here I was manipulating a list. So it was having, I had to write all supporting functions, things like that. So if you are into data frame, so the manipulation is very easy. That is why people prefer pandas. And now, you see the predict classification. I wrote the algorithm for k nearest neighbor. So instead of that, you can write the algorithm for something else, say a support vector machine, random forest. In fact, there is a Python library called scikit-learn. Scikit-learn. This library has all these data methods implemented. All these things implemented. Only thing is that you import scikit-learn, you run a k nearest neighbor. You need not write all the algorithm. See, algorithms are already written, tuned for you. Only thing is that you have to select how many neighbors you need. See, there, just call knn from scikit-learn. Done. So your applied problems, most of the applied problems, you will be using this kind of very quick solutions, where you will write only very little amount of code, but you will apply the machine ideas behind machine learning to your real practical problem. So that is so I will conclude now. Maybe let me stop the presentation. So your remaining courses, for this specialization, one is maths. So in the next semester, there will be a mathematics course, mathematics for machine learning. But you need to know some amount of mathematics. I was mentioning Euclidean distance. Now, you have already learned 3D. You need to know what happens in higher dimensions. If you want to compute distances in higher dimensions between data points, so compute correlation between data points, you need a special kind of maths. Probably some vector linear algebra, some probability, some optimization. So that is what is in stock for you in the next semester. I don't know whether I will be taking, but I will try to take if possible. So, so that you have a real flavor of machine maths for machine learning. And beyond beyond third, then your fifth and sixth semester contains 2 machine learning papers. So in those courses, you will explore algorithms like KNN. So I've just explained KNN. There are many other algorithms, classical machine learning algorithms like your support vector machines, Bayes classifiers, naive Bayes classifiers, or decision trees, etc. There are many things, many algorithms. Right? You will learn how these algorithms will work, and after that, you will look at your in the syllabus. You will look at something called deep neural networks and deep neural networks, which are the now very hot topic in technology. You can build a very good machine learning systems using deep neural networks and the related new technologies that are coming out. And then you will have to do a project based on these technologies later on. So that will be your road ahead. Anyway, I will conclude this course now. I think I have covered almost all things mentioned in your syllabus and a little beyond that. You should actually try to do the programs or try to fiddle with this code that I gave. Regarding evaluation, so we need 2 evaluations and 1 assignment. The assignment I will announce straight away. Assignment will be, I've given you that iris thing. Just now I have explained everything. You convert this into data frame. So don't use list. Your assignment will be to implement the iris algorithm, iris KNN algorithm using a data frame, pandas data frame, instead of the list methods that I gave. So you have to go in the exactly similar manner. You read it into a data frame. You convert or make the data into 3 different categories, or you convert strings to float. I don't know whether this will be, the pandas will read as float or as numbers. You have to explore. Then you have to using those data frame, you should compute nearest neighbors. You should compute neighbors. Of course, you can accept your incoming data as a list or something. Your incoming flower data you can accept as a list and convert into the proper format and give the real values, real category output. I will post some test data for you to explore. So that is your assignment. It's programming assignment you have to do. So everybody has to do it independently. There's no you should not copy. So I think I can very easily, I have that plagiarism checking software. I can very easily compare the similarities between 2 programs. So that is regarding the assignment. And there are 2 exams. The first exam we will conduct next Wednesday. Next Wednesday, there will be 1 hour duration exam. It will be partly coding, partly writing on the paper, kind of thing. I will announce details at least 1 day before how the exams will be there. You can have, we can have first 3 modules. Questions will be mainly on coding, syntax, the first 3 modules. And the last exam or the final exam will be offline in nature. That will happen 1 day when you come back to the college. So I will announce the dates later, via Moodle or via some faculty in your college. So that will be the evaluation criterion. And don't worry, I am here to give you good marks. Don't worry about that. If you do all the assignments, if you write reasonably well in your exams, you will get good marks. Okay. Also, see, those who are attended, they should invariably write the exam. So even if you drop out, if you fail, it doesn't reflect in your mark list. If you fail the exam and drop out, it doesn't reflect. So you are out of the minor. If you pass first 2 courses and drop out later, it also doesn't matter. But your mark list, your final mark list will have Python for machine learning. You have A grade. That will be written. And if you pass all the 5, you will get a degree with a minor in computer science. So that is a scheme. So as far as possible, try to get a pass mark. And there is another option for you. You can take 2 courses from outside. You need not take from our course. You can take 2 courses from NPTEL. I think that option has not yet come for the university. I'm not sure. I have to check it. Either it will come next sem or it has already come. I haven't seen that yet, but still you can check it. So anyway, that was a nice series of lectures that I really enjoyed teaching after a long break. Because I have been running this college for probably around 5 years now. I was out of teaching altogether, mainly into administration, and maybe I used to give some short lectures. But running a course was difficult for me. Actually, the Corona enabled it because I could take it at my leisure. Maybe the scheduling was a little bit odd, but still. That is a good thing. And finally, we will conclude now. One thing that I miss is actually, I don't know any of you. I have never seen your faces. That's a bad thing, actually. And all of you know me. So maybe one day we will meet. Or if you take the next course, I think I will be giving that at least that courses apart from mathematics. Mathematics, I don't know whether I will be given all these 4 colleges, but most probably the neural networks and conventional machine learning courses I will be taking again. I will give an option for you to join that for those from outside. For those who are from inside a College of Engineering, if I take, I will be in online mode then also, not in conventional classroom, but in online. So if you take my course again, please show your face at that time, at least at that time. Anyway, thank you for listening patiently. I think we started off with around 100 and ended up with only 70. Anyway, that is fine for me. Anyway, at least 70 people survived the entire thing. Thank you for the course and for coming to my class. Bye. If anybody has any questions, they can ask, because that question answer session was missing from our course for quite some time. I'll stop recording.